Okay, so let's start off with a review problem. This is a problem that we learned how to do a couple of weeks ago. This is just distributive property. And I want to see if you remember how to do this. So somebody help me out here. How do I solve this? X plus 4 times x minus 4. Yes, sir. That's exactly right. I'm doing the distributive property 2 times. First, I multiply the x by both things. X multiplied by x is x squared. And x multiplied by negative 4 is negative 4x. Very good. And then what Jacob said was, now you gotta do the distributive property with the other number in the first set of parentheses, which is the 4. So we do 4 multiplied by x, which is 4x. And we do 4 multiplied by negative 4, which is negative 16. Okay, so there are two things that I want you to notice about this problem. The first thing that I want you to notice is that the variables are exactly the same. I'm sorry, the parentheses are exactly the same, except one is plus and one is minus. Exact same parentheses, except one has a plus sign in the middle and one has a minus sign in the middle. In Algebra 2, you will learn what these are called. They're called conjugates when they are the same thing but different signs in the middle. You don't need to know that word in Algebra 1, but just in case it comes up on Final Jeopardy, these are called conjugates when they're exactly the same but different signs. The other thing I want you to notice is what happens to these x's in the middle, where we had a minus 4x and a plus 4x. What happens to those? They cancel, exactly right. So my answer is just going to be x squared minus 16 because the minus 4x and the plus 4x cancel out. Excellent work. Now this answer that we came up with, x squared minus 16, is called a difference of squares. And the reason it's called a difference of squares is because, number one, it is a subtraction problem, x squared minus 16, and that's what a difference is. A difference means subtraction. And it's a difference of squares because both of those terms, x squared and 16, are what we call perfect squares. What is the square root of 16? 4. And what is the square root of x squared? 1x, right? X times x is x squared, so the square root of x squared is x. So both of these are perfect squares, and we are subtracting them. This is why we call it difference of squares. We are subtracting two perfect squares. Let's try one more, and then we'll talk about how to factor them. Let's do a 5m plus 1 and a 5m minus 1. And just like last time, we have the exact same thing in parentheses, except one has a plus sign and one has a minus sign. And when you see that, we know that our middle terms are going to cancel out. That happens anytime you've got the same parentheses, but one plus, one minus, the parentheses will cancel out. Okay, so let's do the distributor property. What should we do first? There we go. 5 times 5 is 25, and m times m is m squared. Very good. Okay, and then we do 5m times negative 1, which is 5m times negative 1. Negative 5m. Very good, Aaliyah. Negative 5m. Okay, and then we're going to distribute the 1. So 1 multiplied by 5m is positive 5m. Great. And 1 multiplied by negative 1 is negative 1. Very good job. And just like last time, as we expected, what's going to happen with our two terms in the middle, the negative 5m plus 5m? They're going to cancel because a negative 5 plus 5 is 0. And so our final answer to this problem is 25m squared minus 1. Again, we came up with a difference of squares. It is a subtraction problem, so that's the difference. And 25m squared and 1 are both perfect squares. The square root of 25m squared is 5m, and the square root of 1 is 1. All right, let's pause for announcements. Okay, so now that you have seen kind of a review of multiplication, let's look at what a factoring problem would look like. And so a factoring problem is going to start off with our difference of squares. So it's a difference because it is a subtraction problem. And a squared and 4 are both perfect squares. When you have a problem that looks like this, when it is a difference of squares, we know that our answer is going to have two parentheses, and that one of the parentheses will have a plus sign, and one of the parentheses will have a minus. So right away, I can start off by doing my two parentheses. One will have a plus sign in the middle, and the other will have a minus sign in the middle. So what goes in those parentheses? Well, the first thing that goes in each set of parentheses is what two things will I multiply together to get a squared? In other words, what's the square root of a squared? Jacob? It is a. So these parentheses are both going to start with a. And then the second question that I'm going to ask myself is, what two things will I multiply together to get that 4? What's the square root of 4? The answer is 2. So 2 goes in the next two spots. And that is the answer to this problem. That's what it looks like when it's factored. A plus 2, A minus 2. I could check this by doing the distributive property, of course. Let's go ahead and check our work. A times A is A squared. And A times negative 2 is negative 2A. And then we'll distribute the 2. 2 times A is 2A. And 2 times negative 2 is negative 4. And then, hey, look at that. My A's are going to combine. What's negative 2A plus 2A?
4.
Be careful. One's positive, one's negative. Negative 2 plus 2? 0. And so my answer is A squared minus 4. That's it. That's all there is to difference of squares. If you can square root, this is going to be the easiest thing you've done all day long. Now, granted, school started 10 minutes ago, so all day long isn't that big of a period of time, but still, the easiest thing you've done all day long if you can do squares. Okay, so when we're doing one of these problems, let's take a look at n squared minus 64, the best Nintendo console. The first question I ask myself is this a difference? Am I subtracting? Yes. And then the second question I ask myself is it a difference of squares? Are n squared and 64 both perfect squares?
Yes.
Yes, they are. So that tells me that my answer is going to have two parentheses, one plus and one minus. The plus and minus is what causes the middle term to cancel. Okay, so now that I've got n squared minus 64, I need to figure out what is the square root of n and what is the square root of 64.
What document camera are you done?
It's a scanner.
Okay, where'd you get?
I ordered it through Amazon. Carlo sent it to me. Carlo approved it, yes.
Okay.
And the file that needs to be installed is on the desktop here. I just needed admin permission to install it.
Okay. Can you send me the PO when you get a chance? The PO for that?
I turned it into the front office.
No, I know, but you have a copy of it, don't you?
No, I just handed it to him.
Oh, okay. I'll get a copy from them.
Okay.
Because I need to add it to the work order.
Oh, okay.
So sorry.
No problem.
You have these 3 students, right?
I do.
Could you just pass those out to them for intervention?
Sure.
When we're not meeting today, it'll be whatever the next.
No problem.
Okay.
No problem. Okay, so what's the square root of n squared? N. And the square root of 64? 8. So plus 8 minus 8. And there's our solution. N plus 8, n minus 8. Okay, so all of the examples we've done so far, the variable has come first. Does the variable have to come first? No. What if we made the number come first? What are we asking ourselves? Is this a difference?
Yes.
Yes. Is it a difference of perfect squares? Is 81 a perfect square? Yes. Is x squared a perfect square? Also yes. So we'll have two parentheses, one plus and one minus. And then we fill in our square roots. What's the square root of 81? 9. So each set of parentheses will start with a 9. And what's the square root of x squared? X. That's it. So what happens? What happens if we've got a situation where we've got more than one variable? This one just had x squared. What if we put in a couple of variables? For example, what if I give you, let's do a squared b squared minus 9. That's a difference, right? Are they also perfect squares? Yes. Yes, they are. What's the square root of a squared b squared? It's ab. Very good. Y'all are so smart. It'll be a plus minus. Yes, sir? Okay, sure. So let's go ahead and fill in the last part. What's the square root of 9? So it's AB plus 3, AB minus 3. Okay, what was your question? There are two situations we need to talk about, and one of them is that. What if they're not perfect squares? And the second situation we need to talk about is, what if it's not a difference? What if it's not a difference of squares? So let's talk about what we do if it's not a difference first. So let's do something like x squared plus 16. Now those are perfect squares, but it's not a difference of perfect squares, it's a sum. And even though it really feels like we should be able to factor this, we can't. If it's a sum, it can't be factored. So, for 1,000 bonus points and 50 gold stars, what do you write if it can't be factored?
Undefined.
Undefined is a really good guess. So is no solution. That's a really good guess, but no. Can't be factored, also a really good guess, but we have a word in math that means it can't be factored.
It can be factored.
We say it can be factored, and I just don't feel like it.
Unfactorable.
So prime is exactly right. Aaliyah, can you tell us why we use the word prime? So factoring is asking the question, what can this be divided by? When we factored 81 minus x squared, we were saying, what can 81 minus x squared be divided by? The answer is it can be divided by 9 plus x and 9 minus x. That's what factoring is. What can it be divided by? X squared plus 16 can't be divided by anything. What do we call a number that can't be divided by anything? It's a prime number. So when you come up with a polynomial that also can't be divided by anything, the answer is just prime. And prime means it cannot be factored. That's it. So that's what we do if it's not a difference, if it's a sum. Now let's answer Jacob's other question. Jacob said, what do we do if maybe it is a difference, but they're not perfect squares? Okay, so an example of that might be something like this, 3a squared minus 27. Now that's a difference, But 3a squared is not a perfect square, and neither is 27. Does that mean it can't be factored? It means it can't be factored into two parentheses. But what kind of factoring have we been doing the last 2 days? Right, we can do a greatest common factor, the reverse distributive property. Okay, so what is the greatest common factor of 3a squared and 27? 3. The greatest common factor is 3. So let's take both terms and divide by 3. What's 3a squared divided by 3? 1a squared, good, or just a squared. Great. And then what about negative 27? It's very good. Jacob already told us the answer. It's negative 9. So what are we left with? We've got 3 on the outside, and on the inside, a squared minus 9. Hey, look what's left in parentheses. That looks like a difference of squares to me. Now we can factor what's in the parentheses. You are exactly right. Okay, so do it. A squared minus 9, what will that factor into? Say it again. They'll both start with A, and it'll be a plus 3 minus 3 because the square root of 9 is 3. And then our greatest common factor of 3 just lives right out in front. Is it still going? Yep. So this one we can do a greatest common factor first, and then we can do difference of squares. That's exciting, right? Ansley's with me. Okay, what about this? Is that a difference? Yes. Are they perfect squares?
Yes.
Actually, yes. 4 and 100 are perfect squares, but this one also has a greatest common factor. What's the greatest common factor of 4 and 100? It's 4. 25 is what we get after we divide. You're one step ahead of me. The greatest common factor here is 4. If there is a greatest common factor, we have to do that first. I know when you look at it, you're like, oh, perfect squares, let's go, 2 parentheses. If there's a greatest common factor, though, we got to do the greatest common factor first. Because otherwise it won't be completely factored. I'll show you what it looks like in just a second if you forget to do that. You will get an answer that is correct but incomplete. What's 4x squared divided by 4? Very good. X squared. Fantastic, Aaliyah. And then we've got negative 100 that we're also dividing by 4. And Izzy already told us that's going to be negative 25. So outside the parentheses, we have a 4. All good?
It's still going.
Okay. Thank you so much. I appreciate it.
Yeah, welcome.
So outside the parentheses, we have a 4. And inside, we have that x squared minus 25. Thank you, sir.
Yeah.
Hey, look what's in parentheses, you guys. What's in parentheses? It's the difference of perfect squares. I know. I'm excited too. I thought the problem was over, but no, we can keep going. Don't you look, like when you get to the end of a really good book and you're sad that the book is over? It's like that. Like when we get to the end of the problem, we're going to be sad. So the longer we can make it last. Factor x squared minus 25. And what do you get? Go ahead. Yes. X plus 5 x minus 5 with our greatest common factor of 4 out in front. And there's our answer. Yes, sir. Okay, so using factoring is something that is going to appear in every math class you will take until the end of time, except for statistics. You use it in geometry, algebra 2, pre-cal, and calculus. So there are applications of this in every math class after algebra 1. So I hope you love factoring, because until you are out of school, you will do it in every math class. Algebra 2, pretty much every problem in algebra 2 involves factoring in some way. So we're learning the basics in algebra 1 so that whenever you get to algebra 2, you don't freak out and have a nervous breakdown. But it comes up all the time. All right, let me give you one more problem. I'm going to give you one that's pretty tricky. If you can do this one, you'll be able to handle any of them. 100b cubed minus 36b. The ones we're going to do today don't really get harder than this. So if you can handle this one, you'll be able to do any of them. Yes, sir. So 136 are perfect squares, but you're exactly right. The b cubed and the b, not perfect squares. It's a difference, though. It's a difference, just not of perfect squares. So if they're not perfect squares, what do we look for? A greatest common factor. Exactly right, Austin. Okay, so what is the greatest common factor of 136? It's 4. And then Aaliyah's telling us what the next thing is. One has b squared and the other one has b. So the greatest common factor also includes a b. So 4b is the greatest common factor. So we're going to divide both terms by 4b. Y'all figured that out way faster than I thought you would. You are so smart. Your math teacher must be very inspiring. What's 100 divided by 4? 25. And b cubed divided by b is b squared. Very good. Let's do the same thing with our negative 36. Negative 36b divided by 4b is... It's negative 9. And what happens to the b's? They cancel. B over B cancel. B over B is 1. Negative 9 times 1 is negative 9. So they just go away. So in parentheses, we have 25b squared minus 9. And outside, we have 4b. Hey, look. What's in parentheses? Now we have a difference of squares in the parentheses. Are you seeing a pattern, kids? Do you love difference of squares yet? I will make you love them. 1 plus and 1 minus. What is the square root of 25b squared? 5b, because 5b multiplied by 5b gives us 25b squared. And what's the square root of 9? So plus 3 minus 3. With the 4b out in front. And there's our answer. Great job. 10 out of 10. Does anyone have any questions about difference of squares? Because this last one really is the hardest they get. The hardest they get is you have a weird greatest common factor like 4b, and then you have difference of squares. That's the worst they get.